Wait a second. Hola, hola, hola. Haha, algunas fallas técnicas con nuestro micrófono. Well, we're back, okay? Guys, can you hear me now? Excellent, Abril, thank you for letting us know about that. Now, I was telling you guys, well, first of all, that I'm very happy to be here again with you, and that I'm gonna need your participation, okay? Along all of these presentation, guys, that I have prepared for you, I want you to tell me, from all of the different things that we're going to be doing here, which of the things that we're going to be doing are going to be physical changes or chemical changes. I don't know if you can see the first page of the presentation, guys. It says physical or chemical change. Let's find out. Okay, so that's what we're going to do in this session, guys. If you notice, I have a lot of different things here. I have a cabbage, if you like it. Oh, yummy, yummy. I have some other materials like balloons. I have different sticks. I have pieces of paper. I have some ice. I have some juice, some eggs, a lot of different articles on that other side, and lemon also. We're gonna try to do a series of things with all of this stuff, okay? But I want you to tell me which of the things that we're gonna happen right here are going to be physical changes or chemical changes. Okay, that's gonna be your task in today's session, guys. But first, in order for us to I don't know, develop all of these with kind of a certain order, let's try to remember what is the difference between these two things. What makes a chemical change? What makes a physical change? In what are they different? Can you tell me in the comments, guys? This is something very, very important. If you remember, what is the difference between a physical change and a chemical change? I want you to let me know in the chat, okay? And now, while you are at that, I'm gonna be, I don't know, I'm gonna start with my first material. It's gonna be very, very simple this. I'm gonna start first with physical changes, okay? So I gave you a clue here. Okay, Abril is mentioning that a physical change is the one that can change texture, can change the shape, of course. Maximiliano is mentioning here that a chemical change is that they become liquid. That sounds like a physical change, okay? So if the liquid is still the same substance, we're talking about a physical change, right? That is the main difference, guys. Another example there, it says the chemical is chemical change, that it disappear or change. Excellent, Abril. Yes, a chemical change is characterized by the product, right? But the end product is going to be different from the original, right? We're going to start with something and we're going to end up with something else. That is kind of the main difference between a physical change, in which after the change we still have the same substance, and the chemical change, in which after that change we end up with different things. Okay, so important, very good, guys, congratulations. Now I'm gonna start with the first one, guys. From all that you see me doing here, guys, I want you to write in the chat. For example, I'm gonna be working with sticks right now. So tell me if something I do here is either a physical change or a chemical change. For example, this one. What was that? Was that a chemical change, a physical change? Physical change, easy, right? The first one we start easy, okay? Now I have another stick right here. What happened? What do you think it would be if I burn this stick? I'm not going to do it here because of safety reasons, but I don't know, if I turn this on fire, what change would that be? Am I gonna have a stick still at the end of that? What is gonna be that kind of change? It's gonna be a chemical change, right, Mauricio? Because we're not gonna have wood anymore. Thank you, Leo, excellent. It will become ashes, right? We're not gonna have wood anymore. It's gonna be ashes and some water vapor and some other chemicals in the smoke. Exactly. Now, I think that we are done with this. This was very easy. So we're gonna move to a different material. Now, guys, remember that we also mentioned properties of the different materials. Can you give me some properties of this material? This is a chunk of wood, a little stick of wood. What are its properties? You remember? I'm gonna try to... Yes. So, still a piece of wood, right? Didn't change in another substance. Now the properties. Why did I make that much effort, guys, to trying to break that that material, that piece of wood? It doesn't stretch, right? It's not flexible like this one. It is hard. Excellent. That's another property, Abril. Good job. Now, if we compare it to this one, look how easy I can stretch it. And it is very, very soft. That's another property. What other properties can you tell me about this one? I'm going to try to inflate it. Tell me the properties of this. Okay, what were the properties that allowed me to do this? Flexible, elastic. It's not that hard, right? Because it's kind of squishy. It's not very hard. This one is hard, right? The hardness, that's the property of those type of materials. But this one is very soft, transparent, right? Elastic, excellent. Now, do you think I'm going to be able to break it? No, that's kind of dangerous, I'm sorry. What is the easiest way? Tell me, guys, how can I break this? What is the easiest way? Should I step on it? Should I crush it? What? It contains air, very good. I want to break it, I want to burst it. So, what should I do, guys? Do you know ways to break it? With my feet. It's going to explode, of course. Now, let's try to do that. Careful with your ears. I recommend you to lower the volume. Did you hear that? By any chance? Okay. Now, give me a minute. It blew too hard, but here it is. Okay? Did it change its materials, guys? Did it change it? Did it turn into some other stuff? So that was a chemical change or a physical change? The explosion. What do you think? Did it turn into a different... It's still a balloon, right? It didn't change to other things. So we have what kind of change here? Mauricio, his head was blown up. It's a physical change. Excellent, Abril. It's a physical. Okay, guys, now I am going to give you the last example of this series of physical changes, okay? This is a very common material, right? Now, another thing, important thing that I want you to focus on for this activity, guys, is that with the change on the properties or with the change in the materials, the function also changes, right? Rest in peace, the balloon that died. Sorry about that, guys. It's for scientific purposes, okay? I hope that you can understand. Anyway, so with this material, guys, I was mentioning that there is another important characteristic with the change in function. I'm sorry, with the change in the materials or the properties of the material, the function also changes. Now, this is going to be kind of a challenge for you, and you're going to transform that into a challenge for me. Okay? Your challenge is to tell me in the chat what different articles can I make with a piece of paper. Very, very quickly, guys. So, because I have to do it, okay? You're going to tell me what you want me to do with this piece of paper, and I'm going to try to do it, okay? So, any ideas? What is the easiest thing that you can make? Art. But an example in which way? A drawing. I don't have any pen. Do you have any pen, teacher? Drawing. I'm sorry, I'm going to go for this pen. Okay, that's a very good example. Origami, a cat maybe. How can you make a cat? I'm going to just make something very, very basic because, I don't know. Here is a little bird, I think. Ta-da! So this is my piece of art, okay? That is something, oh, I don't know if you can see it because the light is so bright. It is a tree with a little nest there and a bird, okay? So this is my piece of art. Now, an airplane. So we saw a function of this paper right here. I can use it for making art, right? I can wrinkle it, yes, of course. I can do some origami. Actually, I don't know a lot of shapes. But an airplane, I can try to do it very quickly here. Steps two. Very, very quickly. I'm sorry if it's not perfect, but we don't have that much time for all of the details, okay? What's the next step? So guys, do you know which is the best model for these paper airplanes? I love doing these things. I like the concept of flying and all of that. And okay, now what changed in this material? What changed? What was the change? Previously it was all flat, right? A single piece of paper. Now the shape changed, right? And with that change of shape comes another function, right? There it goes. It works. Okay? So, you told me also that you can wrinkle it. You can do that. You can use it as a projectile or something. You can put it back as it was before. Steel paper, right? The material didn't change. The composition, I mean, it changed the shape, it changed the space it occupies, and so on. You can make boats also, a lot of different shapes that you can make with paper, right? This is a very flexible material. It is resistant also, a little bit resistant to water also. You can put your little boat of paper, right? And have fun. Now, guys, this is another example that I wanted you to see. It's also very simple. I don't know if you can see what is on this lid. It is a piece of ice. Actually, there are several pieces, several cubes of ice clumped together. But if you can see here, guys, there wasn't any liquid at the moment that I place it on the lid. Now, I don't know if you can see it, but it changes the state from solid to liquid. I have some water right there. I don't want to spill it, but I just want you to see it, okay? There it is, the water, okay? So a change of state, it's also a physical change, and we didn't change the substance, okay? Now we're going to move on to the chemical examples, the chemical changes. Thanks for the pen, teacher. I'm gonna give it to you at the end, okay? Now, the first example that I want to show you here is this. Maybe this was a very common experiment in the science fair projects for PEP. This is called a bouncy egg, o el huevo rebotón si quieres, something like that, okay? If you notice, this is an egg, but I don't know if you can check the texture. It is kind of squishy. Normally, you don't find your eggs like this in the fridge, right? Look at this. It bounces, I can let it fall from this height, right? And it's bouncy, right? Now, I want to show you how I made this. This was a chemical change, guys, a chemical reaction. I want you to look at this egg. This is a fresh egg, right? It's right there. Solid. Now, the shell is composed by calcium carbonate, carbonato de calcio. This, what I have here, guys, is vinegar. Of course, some of you know about this experiment already, right? Now, I would like to make a close-up of this. I'm going to go closer. What I want you to see here, guys, is the reaction happening, okay? You will be able, I'm going to step a little bit further here. Okay, hopefully you can see it, guys. At the moment that I pour this vinegar, it is an acid, acetic acid. You can see how immediately there are some bubbles already forming, right? Exactly, it's going to kind of melt the shell, right? Can you see the bubbles? That is kind of the evidence for our chemical change happening, okay? A substance is being transformed into other, right? Okay, now, if I leave this kind of 24 hours from right now, from on until tomorrow, it's going to look like this, and it's going to be all bouncy because all that calcium carbonate is going to be gone, okay? The acid is going to change it, right? The bubbles that we saw there is because the acid is kind of extracting that carbon dioxide from the shell, and it's kind of, as some of you saying, it's kind of melting it, something similar like that, okay? But that is an example of a chemical change. At the end, you don't have the same thing, right? Where is the shell? You have something different, right? Now, I have another example right here. For this, I will have to pour something. I hope I don't make a mess right here because I will have to clean it. So I hope to aim properly. Now, guys. Okay, I'm going to try again. This is very, very hard. Hopefully, most of it's going to fall inside, okay? Don't expect too much because my pulse, no, I'm sorry. I will have to just clean after, okay? There it is. Oh, I'm getting better. Okay. Maybe you're wondering, what am I serving here? If that is the case, guys, I'm just going to tell you that juice comes from this vegetable. Do you know what is the name of this? If you like vegetables, can you tell me what is the name of this beautiful, beautiful vegetable? Guess. Can you tell me? If you know the name, put it in the chat. Let's see how much you know about plants or cooking, maybe. Es una coliflor. Exacto. You're right, Abril. Right? Okay, I cleaned as best as I could. Now, okay, so this kind of cabbage is a very peculiar one, right? The color, in English, it is known as red cabbage, but actually it looks a little bit more like purple. I don't know if you agree with me. Actually, in Spanish, it's known as col morada, but in English, it is known as red cabbage, okay? Now, this is a cabbage. Red cabbage in English or col morada in Spanish. Okay, so why does it have that color? It has that color because some plants have these very peculiar, very special molecules that are called flavonoids. Flavonoids, some molecules that give some colors to the plants. In this case, the flavonoid that we are witnessing here in this cabbage is anthocyanin. Okay, it's an anthocyanin, which gives colors from the range of blue, from purple, a little bit of red also. When you see a plant with those colors, it's because it has those molecules, anthocyanins. Now, these anthocyanins have a very peculiar way to behave. I'm going to advance this presentation. Okay, guys, so can you see these kind of chemical structures there in your screen? If you can see them, you're going to notice that the shape of that molecule is almost the same. It only changes if you add these groups, a hydrogen or a oxidryl or a hydroxyl with an oxygen with an hydrogen together. Those groups have different properties, guys. If you have more quantities of hydrogens, H, you're going to be in more acidic environments. Right? And the color in those conditions is going to turn reddish, it's going to turn a little bit more, I don't know, with those tonalities, okay? Orange, red. The more acidic it gets, the more red it gets, okay? And on the other hand, the more alkaline, the opposite of acidic, right? The more alkaline it gets, you could get tones even yellow or greenish, something like that, okay? Now we're going to try to make kind of that range of colors here with different products. Ta-da! So if you wondered if a lemon is kind of acidic or basic, we have also vinegar, a soda, we have water, we have sodium bicarbonate, and some cleaners, okay? Now I'm going to start with the first one. Remember, this is, maybe I didn't mention before, it's the pH scale. The pH measures if something is acidic or alkaline, okay? If you notice a red coloration, it's because we are going to be in the presence of an acid. If you see a coloration that goes from green to yellow, something like that, it's going to be something alkaline, okay? Now we're going to start with this. I'm going to cut this lemon, guys. When I'm cutting it, what type of change am I doing here, guys? If I cut the lemon, does it transform into an apple? Obviously not, right? So the substance didn't change. I'm going to add a few drops here and let's check the change in color. I don't want the seeds to fall in. Oh, okay. So did you see that? Remember, guys, that chemical reactions are witnessed, or we know about a chemical reaction, that a chemical reaction is happening if we see bubbles, if we see the change in color, and something like is kind of a change in temperature also. It could get warmer, it could get colder, right? So that is lemon juice. Was it an acid or an alkaline, guys? Do you remember? Now I'm going to pour some vinegar, little drops. Hopefully I don't pour it all. Oh, that was too much, I think. Anyway, so if it is red, is it an acid or is it a base, guys? There you have it, vinegar. Now, I have to prepare this right here. I'm going to dissolve a little bit of sodium bicarbonate. Okay, I'm a little in a rush, guys, because I don't have too much time left, but I'm going to try to do my best here, okay? This is sodium bicarbonate, right? I'm going to make a little solution here. And we're going to check if it is more acidic or basic, okay? Okay, I think that's enough. I'm going to pour a little bit of this here. Let's see if we see some change in color, okay? I'm gonna use this one. So guys, this change in color that we are observing here, it's kind of that evidence for the chemical reaction or the chemical change happening, okay? I'm gonna skip this one here. I'm gonna use the soda, of course. Why do you think we chose soda that is transparent? I'm gonna pour it here. Okay, some acids right here. We can see this range of colors, right? So, and the next one, I'm going to pour a little bit of water. This is just tap water. Do you see any change there? Looks the same for me. I don't know. Okay, this was the sodium bicarbonate. Now, I have some cleaner here. Okay, I'm gonna break this one. Use it as a stir. Right there. And the last one is gonna be the chlorine, okay? I hope I don't pour it too much. So it starts kind of with a greenish color, right? Because the reaction is just beginning. But later it gets from this other color. Right? Very bright yellow. I'm going to try to repeat. I have this other. Oh, I think it was too much of the first cleaner. Let me see if I can get another color. Maybe only one. Hopefully it stays that color. I can use this one. Okay, we're going to remove this one. Now guys, so change in color, evidence of a chemical reaction. From this end of the spectrum, we can see alkaline solutions. This is sodium bicarbonate. This is this detergent. Cleaners are almost always alkaline or basic, and this is chlorine, okay? We can see it at the end. This one here is, I think, is the soda. This one is the vinegar, and this one is the lemon juice. So there you have it, guys, the change of color. Now, we're about to finish this, guys, with another example of a chemical reaction, right? I hope that you like it. For this, I'm going to ask here the producer to turn off the lights. Don't worry. It's going to take a while, so please be patient, okay? Give me a second, I'm going to work on something and I'm going to show it to you later. We don't have suspense music in the meantime. It takes a while, so I'm sorry about that, guys. But I hope that you like it at the end, okay? We can leave those on by the moment. This was a little easier when I rehearsed, but anyway, let's give it a try. Okay. Okay, just be patient, guys. It's gonna take a little bit of time, but I think that you're gonna like it, okay? Okay, we're almost done. Just give me another second. What do you think it's gonna be, guys? I hope that you like it. Oh, these are not very good. Okay, hopefully with this we can make it. Yes, I'm actually missing that. I'm sorry guys, I didn't prepare this kind of suspenseful music. But let's try to do it like this. Good. Okay. I'm not a very good artist, guys, but I hope that you like it. So, teacher, could you help me please now turning the lights completely off? Thank you. Okay, guys, so with this chemical reaction, I just want to say, da, 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 da. I don't know if you can appreciate it, but thank you, okay? Thank you for your participation, for your patience. And I want to say goodbye with this chemical reaction, okay? So thank you guys. And I'll see you later on class, okay? See you.